Good evening all. My name is Sreeram. My tag number is GTC 01211009. I am studying Diploma in Tool Engineering and Digital Manufacturing. Currently, I am studying 4th semester at Gannavaram Training Center. Today, I am here to present my short talk. My topic name is Electron Beam Machining. Today, I will explain about introduction of Electron Beam Machining, working principle, parts of EBM, applications, advantages and disadvantages, and I will show you a video. Electron beam machining is a non-conventional machining process. High-speed electron impinges on your workpiece, conversion of kinetic energy into heat energy. Let us see the working principle of electron beam machining. In electron beam machining, electrons are emitted by a hot surface and accelerated voltage of up to 10 to 50 kilowatts are focused to a very small areas on the workpiece. In electron beam machining, focusing of high velocity beam of electrons on your workpiece when this narrow stream strikes the workpiece. By the impact of the kinetic energy of the electrons is converted to powerful heat energy, which is quite sufficient to melt and vaporize any material. Even though the electrons can penetrate metals to a depth of only a few atomic layers, the electron beams can melt metal to a depth of 25 mm or more. The electron beam, which travels at about half to 3 to 4 the velocity of sound, is focused on the workpiece by electrostatic or electromagnetic lenses. EBM is done in a high vacuum chamber to eliminate the scattering of the electron beam as it contacts the gas molecules on the workpiece. The most commonly used electron beam power are 1 to 25 kilowatts and current is equal to 0.001 amps. Since a continuous beam processes considerable heat by conduction through the workpiece, a pulsed beam at a frequency of less than 100 CPS. CPS means cycle per second. Is used in electron beam machining. Let us see the parts of electron beam machining process. There is a U-shaped chamber object called cathode grid and it is connected to a high voltage cable of 30 kilowatts direct current and it transmits the electrons. It is made up of tungsten and the electrons moves towards the anode and there is a valve and the electrons are streamed and enters into the magnetic lenses and the magnetic lenses shapes the beam and does not allow to diverge the electrons and it moves towards the deflection coils. And the deflection coils is also called as electromagnetic lenses and it concentrates the electrons towards the workpiece. There is a blue color chamber called vacuum chamber which is used to clamp the workpiece with the help of some fixture. Let us see the applications of EBM. Micro machining operations on thin materials also can be done. These operations like drilling, perforating, slotting, scribing and engraving. A micro machining technique is called electron beam lithography is being used in the manufacture of field emission cathodes, integrated circuits and computer memories. Let us see some more applications of EBM. Very small holes such as 0.03 mm holes also can be produced with the help of EBM with high surface finish of 0.4 to 0.6 microns. EBM is being used to drill holes for the following products such as thousands of holes in turbine blades for transmission cooling, holes in mixture plates, combustion chamber rings, metering or flow orifices. EBM is particularly useful for materials with high melting points and low thermal conductivity. Let us see the advantages. It is excellent process of micro finishing. There is no further finishing operations required after electron beam machining. Very small holes can be produced in any material with high accuracy. Complex shapes also can be machined. No mechanical contact with tool and workpiece, so there is no tool wear. Let us see some more advantages. Very hard and heat resistant materials also can be machined. We can achieve very close dimensional tolerances with the help of EBM. Heat affected zone is minimum. Let us see the disadvantages of electron beam machining. It can be used for very small cuts only. Vacuum requirements limits the size of the workpiece. That means vacuum requirements which, which is used to equipment of cost is high. The metal removal rate is very low. Let us see a video.
Today we will discuss about electron beam machining, how electron beam machining will work and what are the parts of the electron beam machining. Firstly, discuss about the parts of the electron beam machining. We have a vacuum chamber in which the whole process will be carried out because air will not interrupt in this vacuum chamber. So, losing of the velocity of the electron will not occur. There is a grid cup is called cathode, which is connected to the high voltage cable, which is 30 kilowatt DC power supply. And after this we have anode, then diaphragm, then we have an optical viewing system, then magnetic lens and deflection coil, and in the vacuum chamber we have also a workpiece on which all the process or all the experiment will be carried out. This is a fixture for workpiece. Now what will happen when this high voltage cable give DC voltage to this cathode, means negative to this cathode, then electron will be liberated from this grid cup and they will be accelerated by the anode, and electrons will travel like this path. They will go through the diaphragm and reach on the magnetic lens. Magnetic lens will focus all the electrons and this deflection coil will deflect the beam. These all will work and deflection coil will deflect the beam on the workpiece, and this workpiece where the beam will strike molten metal, or we can say that metal removal will takes place. Metal removal air will not interrupt with the
By the video, we learn about the machining process of electron beam machining. And in this session, we learn about applications of EBM, working principle of EBM, advantages and disadvantages of electron beam machining, and a video. Thank you.